Superposition also can be happen in sound wave. Okay, as we can see here, we have a system or an apparatus of a speaker with the tubes, T junction tubes. We have a speaker label S, and then we have the listener here, the ear of the listener at label R here. So the speaker is labeled S, so this is a speaker, and the listener label R is the receiver. Okay, we have also the path length. Okay, the path length of R2 and path length of R1. So as we can see here, as we can observe here, we have two T junctions here. T junction at point P, this T junction, and another T junction is at point Q. The sound from the speaker label S is sent into a tube at point P. Sent into a tube at point P, so we have here the speaker. The sound from the speaker is sent to a tube at T-shaped junction. The sound and then split into two separate pathways. We'll go to path of R2, another path to the path length of R1. Half of the sound travels upward. Okay, half of the sound travels upward. Half of the sound travels downward. And finally, the sounds merge at the receiver, which is at the opening where the listener places the ear, which is at the receiver. We have two path length, R1 and R2. R1 and R2. Okay, if R1 is equals to R2, or in other words, we can say if the two path lengths have the same length, the waves that enter the junction will separate into two halves. It will travel two paths and then combine again at the ear or at the receiver. And what happened here at the receiver? The sound wave reunited and produces constructive interference. So at this point are sound wave reunited and produce constructive interference. And what happened? The listener can hear a loud sound. We can say a listener can hear a loud sound. So this is about the acoustical system for demonstrating interference of sound wave. Okay, next we have superposition of two identical waves. We have three figures, 17.4a, 17.4b, and 17.4c. So we have three different figures with two waves for each figure. For example, okay, we have figure A. These two waves on figure A are in phase. They are in phase to each other. and therefore it is indistinguishable. And figure B is showing two waves, two individual waves, 180 degree out of phase. 180 degree out of phase. So figure A will have constructive interference. Figure B, two waves will encounter disruptive interference. And figure C is showing there are actually three waves over there, Y, Y1 and Y2. So this one, the intermediate result is neither constructive nor destructive.